So today we started solving systems of equation using the elimination method, and we start off with the easy type of problems. Now let's go over the steps for solving systems of equations using the elimination method. The first thing you want to do is you want to add or subtract the equations to eliminate one of the variables. The next thing you want to do is you want to solve the resulting equations for the remaining variable. So if you eliminated the x's, you're only going to have y's, so you're going to solve for the y's, and vice versa. And the next thing you do, you substitute the value from step 2 into one of the original equations, and then you solve for the eliminated variable. This is the exact same steps numbers 2 and 3, the exact same steps that we use for the substitution method. And so is number 4, where the final step is to write the solution as an ordered pair and to check your solutions by substituting into the original equations in the system. All right, so let's go ahead and start with number 1. Here we got number 1. First thing you want to do is you want to look to see if there are any opposites. Here the coefficient for x is positive 2, and the coefficient for the x in the second equation is negative 2. And since they are opposites, we're going to add them together. 2x minus 2x eliminate, and 4y plus 3y equals 7, and negative 20 plus 6 is negative 14. And so we have an equation of 7y equals negative 14. We solve for y, and we have a solution of y equals negative 2. So we've already done steps 1 and 2. Next thing you know in step 3 is we're going to substitute our value of y into one of the original equations. And so I chose the first one. Instead of 2 times x plus 4 times y equals negative 20, we're going to end up with 2 times x plus 4 times negative 2 equals negative 20. And then we have an equation, so we use don't come in algebra match-up. We distribute positive 4, negative 2. We undo our constant. And then we undo multiplying or dividing of a variable term, and we end up with the solution of x equals negative 6. And so we write our solution as an ordered pair. Now for the sake of time, I'm not going to check my solutions, but this is the correct solution. Let's try the next problem. Here we have this system here, and we're going to use the elimination method. So let's look to see if there are any equations that have the opposite coefficients that can be eliminated. And yes, we do. We got negative 3x and positive 3x. So we're going to add them together. 3x and negative 3x cancel out, so we end up with 6y equals negative 36 when we add 3y plus 3y, and negative 6 minus 30. And now we solve for y, and we divide both sides by 6, and we end up with the solution of y equals negative 6. Now we're going to substitute this value into one of the equations, your choice. I went ahead and chose the second equation. Instead of 3 times x plus 3 times y equals negative 30, it's going to be 3 times x plus 3 times negative 6 equals negative 30. And we use don't come in algebra match-up. We have distributive property. Then we're going to undo our constant. And we end up with 3x equals negative 12. So we divide both sides by 3, and we have a solution of x equals negative 4. And in step 4, we write our solution as an ordered pair, and we check our solution. And after checking this in my head, that is the correct solution. Now here's a different type of problem. If you guys look at the equation, we do not have any equations that are opposites. So what we need to do is we need to change one of the equations. Now how do we make something become the opposite? Well, we have positive 2 and positive 2, and in order to make it the opposite, we're going to multiply the second equation. You can do the first one if you want, but I'm going to multiply the second equation by negative 1. And so I'm going to distribute negative 1. So let me go ahead and rewrite the first equation. And then when I distribute negative 1 in the second equation, we end up with negative 2x minus 2y equals 0. And so we end up with a solution of x equals negative 4 because 3x minus 2x equals x. Positive 2y and negative 2y cancel out, and negative 4 plus 0 equals negative 4. Now we take that negative 4 and we substitute into one of the equations, one of the original equations, and I'm choosing the second one. Instead of 2 times x plus 2 times y equals 0, it's going to be 2 times negative 4 plus 2 times y equals 0, and we have an equation. And we use don't come in algebra man. We distribute. We end up with negative 8 plus 2y equals 0. Undo our constant. We end up with 2y equals 8. And after dividing both sides by 2, we end up with the solution of y equals positive 4. And so our solution is the ordered pair negative 4, positive 4. Again, you're not always going to have two equations that are eliminated. You're going to have to come up with equivalent equations to make sure you are able to eliminate them. Let's try another one just like this problem. Here, you can see that positive 4 and positive 4y, they cannot be eliminated because if you add them together, you end up with 8y. So we're going to have to multiply both sides of the second equation by negative 1. So let me write the original first equation, and now I'm going to distribute negative 1 to the second equation. Negative 1 times 2x is going to be negative 2x. Negative 1 times positive 4y is negative 4y. And negative 8 times negative 1 is positive 8. Now 4y and negative 4y are going to cancel out. So we're going to subtract 3x minus 2x, that equals x. And negative 4 plus 8 is positive 4. We end up with x equals 4. Now we're going to take that solution and we're going to substitute it into this first equation. It doesn't matter which one. So instead of 3 times x plus 4 times y equals negative 4, it's going to be 3 times 4 plus 4 times y equals negative 4. So we distribute. Then we undo our constant of positive 12 by subtracting 12. We end up with 4y equals negative 16. We divide both sides by 4, and I end up with the solution of y equals negative 4. Now we write our solution as an ordered pair. The solution is the ordered pair 4, negative 4. And again, I don't have time to check, but this is the correct solution because, well, I know it is because I have the correct solutions. And so this is how to solve systems of equations by elimination. And these are the first type of problems that we did today. Later on, it's going to get more complicated, but here is just the basic introduction. And I hope this helps you guys with your homework. If you have any questions, you guys know you guys can see me before school or after school. And I hope this video has helped you. Thank you for watching.